All right, so we're going to start by taking a look at section 2.3, which is on solving linear equations, which is something you would have done in Algebra 1, and quadratic, also Algebra 1. But we'll kind of go through it, especially when you get to quadratic, talk about the different ways. There's factoring, there's quadratic formula. There's different ways we can do it. All right, so we'll just kind of review that. Okay, so first, just a reminder, what makes something an equation? Well, it has to have an equal sign. Okay, so anything that has an equal sign in it, that's an equation. On each side of the equal sign, you have to have an expression. Okay. So, for example, that's an expression. That's a numerical expression. That's an algebraic expression. Anything with a letter is algebraic. Put an equal sign between them. There you go. Now you have an equation. Depending on the letter that you use, we can describe the equation and say, for example, this is an equation in x. In x just means x is the letter that's being used as the variable. That's all. When we're setting up equations, x is probably the most common letter we pick, especially for the independent variable. But if you're doing a word problem and it makes more sense to choose a different letter, you can. But x is what we use quite a bit. Okay, so solve an equation. What does that mean? Okay, when we're solving it, it means to find all the values of x that make it true. For that equation up here, how many different values make this equation true? Well, how many? Well, just one, yeah. Linear equations, generally the most common case is to have one solution to it. So in this case, x would be 4, and that is the only answer. When we get into quadratic equations can have 2 different answers. Okay, so one kind of equation is what we call an identity. And I think I've got an example right there. So let's start to solve this equation and see what happens. Okay, what would be your first step on the right-hand side if you were going to start to simplify, solve that equation? So that's the left-hand side. What would you do first on the right-hand side? Yeah, let's distribute the 3 out. And you get 3x plus 2 equals, and then if we distribute the 3, it's 3x plus 3 minus 1. And Christian, if I combine like terms on the right-hand side, what will I get?
You'll get 3x plus 2.
Right. Okay, so I have 3x plus 2 on the left, and I have 3x plus 2 on the right. Now, you might say, well, next I'll bring all the x's to one side. You can do that, but you're going to end up with 2 equals 2. Whenever all the letters cancel out, and you end up with a statement that's true, that's an identity. What that means is no matter what value you plug in for x, it would always work. Okay? You can't find an equation, you can't find a number to plug in for x that wouldn't work. Every single number would work. It's because you have the same thing on the left and on the right. Any questions on why that's an identity? And that's kind of a special case. It usually doesn't happen that you get exactly the same thing on the left and on the right. What usually happens more often is you have what's called a conditional equation. So a conditional equation is when there is specific values that make the equation true. Right? This equation isn't true all of the time. Okay, the top one is. But this one's only true if you let x equal 5. Okay, so that's the condition that makes it true. X has to equal 5. Any questions on that? Just going through some of the different terms and the different kinds of equations you're going to see before we actually start solving. All right, so sometimes what they have us do before we finish the question, they have us check our answer. So if they ask you to solve and then check your answer, just take the number that you get and plug it back in and see if you get a true statement. So if we go back to this problem, let's say I think x is 4. If I plug 4 in for x, 2 times 4 gives me 8, and I get 8 equals 8. That's a true statement. Same number on both sides. Let's say I made a mistake and I thought x was 6. Maybe you minus 2 from both sides instead of dividing by 2. So if you plug 6 back in, you get 2 times 6 is 12. Then you get 8 equals 12. That's not a true statement. Okay. So one of two things, you either plugged the wrong number back in, so you didn't get the right answer, or you made a mistake when you were checking your answer. Okay. Any questions on that one? Okay. So this one, they're not asking us to solve it. They're already giving you a number, and they just want you to check if it's a solution. Okay, so they want you to do the verify, which is what I just described right here. Okay. How do I verify that -2 is a solution to that equation? Yeah. Yeah, just plug it back in. Everywhere you see an x, change all the x's to -2. And the hope is when we do out the left-hand side, we get 0, because that's what's on the right-hand side. Okay, so we've got -2 cubed. And then you've got minus 2 plus 6. And the question is, does that come out to 0? Addison, what's -2 cubed?
8.
Careful, it's a negative times a negative times a negative.
Negative.
-8, yeah. So you get -8. And Remy, what about when you minus a -2?
And plus 2.
Yep, that's going to become +2. So that will simplify the left. Jade, what's -8 plus 2?
-6.
And then -6 plus 6?
0.
There you go. So does that mean -2 is a solution or is not?
Is
It is, yeah. Because we got the same thing on both sides, and we verified that it is a solution. Okay. Questions on that? Okay. So now, that was a cubic. Okay, we're not going to jump into solving ones like that right away. We're going to start with linear. So that's a linear equation. Anything that can be written in the form ax plus b equals 0. Okay, that's a linear equation. So an example is 2x plus 3 equals 0. So any equation that you set equal to 0, and it has a number with x to the first, and then just a constant. Even if it doesn't look like that at first. Let's say you had 2x equals 4 plus 5x. You might say, well, that's not equal to 0, so that's not linear. Well, if we could rearrange it, then it still could be. I could minus 2x from both sides. And I get 0 equals 3x plus 4. Okay. So anything that can be rearranged to look like this is what we call linear. I'm not saying that's how I'd want to solve for x. I'd want to put the 3 on the other side and then divide by 2 to solve for x. But that's what, it's kind of like y equals mx plus b. Okay. Anything that looks like that is linear. So you cannot have anything with like x to the second power. That would make it quadratic. You can't have anything with letters in the bottom of a fraction. That would not be linear. You can't have like a square root of x plus 4. Nope, square roots, that's not linear. Okay, it can only be an x to the first power, and then plus or minus a number. So I can put a minus there as well. All right, so let's see if we can solve this equation. The way it looks, doesn't look linear right away, but if I kind of scan it, there's only x to the first powers. There's no x's in the bottom of fractions. There's no square root of x's. So when I do all this out, I could make it look just like that. All right, how about, Ruben, what's going to be my first step on the left side? Yep, and what number are you going to distribute first?
First pair.
Yep, and you're distributing
2 and 2x.
Yep, and what else?
2 and negative 3.
Okay, can you tell me what you get when you do that part?
You get 4x minus 6.
Perfect, 4x minus 6. And Serenity, what else do I still have to do on the left-hand side?
Distribute the other one.
Yeah, we got another distributive property. And what do you get when you do that one?
3x
3x
plus 3.
plus 3. Yep. For the right-hand side, we're going to keep it the same at this step. How about, Gianna, what else can I still do on the left-hand side? Yeah, I've got some like terms I can combine. What are a pair of like terms?
4x and 3.
Okay, so 4x and 3x, and when you combine those, you get how much? 7x. Anything else, Lucas, I can still do on the left side?
Combine negative 6 plus 3,
Yeah, I got some more like terms. And negative 6 plus 3 gives me?
negative 3.
Yep, negative 3. All right. How about Ryan, what would I do next?
Bring like the 5x over.
Okay, we could bring the 5x over to the left side. How would you bring that over to the left?
Minus 5x.
Yep. Okay, so minus the 5x from both sides, it's gone on the right. And Kim, what's 7x minus 5x?
2x.
So we get 2x. Just bring down the minus 3 and the plus 2. And now we're starting to see how it's looking pretty similar to this. Okay. If I wanted to get it equal to 0 right now, I could by just bringing the 2 to the other side. That wouldn't help me solve for x. But I could make it look exactly like this. Okay, so it is linear. So Christian, what would be my next step if I'm trying to get the x alone?
Just take the 2 over there.
All right, so what would you do on both sides?
Subtract 2.
So that's going to put more stuff with the x. We want to try to get stuff away from the x.
Oh, I mean, add 3.
Yeah. So we're going to add 3 to both sides. Okay, that's going to cancel out the negative 3. Now we're down to a one-step equation. Okay. My last step, Quinn, would be to
Divide by 2.
Yep, divide by 2. And we can just leave our answer as a fraction. No reason to change to a decimal unless they ask us to. Okay. So, any question on solving that equation? So hopefully something that you remember probably reviewed last year and then would have probably done freshman year as well. All right, so another kind of equation we're going to look at, which is linear when we split it up, is absolute value. Does anybody remember, what are the symbols that we use? Those two lines, right? Like those two bars? So the absolute value bars, they look kind of like that. And the way that we're going to solve the absolute value expression is we're going to split it up into two problems. But we can't split it until we make sure the absolute value is by itself on one side. So here's an example. I thought I had one. I guess I'll just make one up. Here's an example of an absolute value that is all by itself on one side. Okay? That has the absolute value isolated. Here's one that does not. How come in the second one the absolute value isn't by itself? Yeah, it's got this plus 4. Okay? So the first thing we'd have to do on this problem is minus 4 from both sides, and then that would isolate the absolute value. I'm not going to solve this one. I'm just showing you how you would isolate the absolute value. Okay. Same idea if you had a number in front, like 3 times the absolute value. That's another example where absolute value is not alone. You're going to have to move the 3 to the other side. How would you move the 3 this time? Yep, divide by 3. Exactly. Okay, so that's always the first step. Make sure the absolute value is isolated. Then we're going to split it into two problems. The first problem that we're going to split it into is the exact same problem. Just take out the bars. That's all you do. Just write down the exact problem that I give you, but take away the bars. And the second one, okay, so that one's a little different. You're still going to write down the exact problem I give you without the bars, but you're also going to make the number on the other side the opposite. That's what negate means. Just make it the opposite. Yes?
Can you just go back?
Well, okay, so first equation, copy down the original without the bars. Second equation, copy down the original without the bars again, and make the number on the other side the opposite. So generally, we're going to have two equations we always have to solve when we do absolute value. They will both be, for what we're doing, they're both going to be linear. But they're generally not as complicated of an equation as this one. They're much simpler. All right, so let's see if we can solve this one. Absolute value of 2x plus 3 equals 5. Okay, first step. Make sure the absolute value is isolated on one side. Is the absolute value by itself here, or is there something we need to do? Yeah, it's already by itself. So we're ready to go right into the part where we're going to split it. Split it into two problems. Okay. First problem. Basically copy down the original equation. We just don't write the bars. So what's going to be the first equation that I solve? Yep.
2x plus 3 equals 5.
2x plus 3 equals 5. Okay. Second equation, do the same thing again, but this time make the number on the other side a negative. Okay. Yep.
Yeah, 2x plus 3 equals negative 5.
2x plus 3 equals negative 5. Okay. And now we've got two linear equations to solve. And they're very similar in terms of the steps. It's exactly the same steps to solve both. So Madison, what would be my first step to solve the one on the left, or the one on the right?
Subtract it.
Yep, we're going to subtract the 3. That's going to cancel. We get 2x equals 2. And Jaden, my last step.
Divide both sides by 2.
Divide both sides by 2. That's gone. And that gives me an answer, one answer of what?
X equals 1.
X equals 1. Okay, so that's my first answer. And now do exactly the same steps again. Minus 3 and divide by 2. Okay, so 3 is gone. What's negative 5 minus 3? Negative 8. And divide by 2. And the other answer we get is x equals negative 4. Yep. And that's how you solve absolute value equation. Any questions on that? So the last thing we're going to look at for, actually, let's do one more thing here. Let's just look at this one for a second. Does anybody notice anything about that one if you were to try to solve it?
It's not
Why is that impossible?
because you can't get a negative out of an absolute value.
Right. No matter what you plug in for x, absolute value bars means to take whatever you get here and make it non-negative. Well, you're never going to get negative 4 when you try to solve this. So that would be a no solution. Okay? If you ever have absolute value equal to a negative, don't start splitting it up into two problems. That's no solution. But what if I had something like, let's say, negative 5 plus the absolute value of x plus 1 equals negative 2.
That's
You
possible.
gotta get the 5 over.
Right. You might say, well, wait, you just said if it's equal to a negative, you can't do it. But that's after the absolute value is by itself. When you add the 5 and get it by itself, it's not going to be negative on the right side anymore. It's going to be the absolute value of x plus 1 equals 3. And that's very doable. You get x equals 2, and you get x equals negative 4. And you can always check by plugging it back in. 2 plus 1 is 3. Take the absolute value of it, you get 3. Negative 4 plus 1 is negative 3. And what's the absolute value of negative 3? It's also 3. Yeah, so both those answers work. All right, any question on that? All right, so last thing with linear equations before we go to the final kind of problem, which is quadratics. Okay, so mixture problems. When we solve a mixture problem, we're going to have to set up two equations. So the way that this kind of problem is going to work is I'm generally going to say something like you've got a solution. Let's say you're mixing two solutions. One solution is 10% strong, the other solution is 30% strong. Okay, whatever the solution happens to be. I think we can do a lot of solutions where it's like mixing two solutions that are like concentrations of like rubbing alcohol or something like that. Okay. So you got a solution that's 10% and you got one that's 30%. I want you to mix the two together. So when you're done, you have a solution that's, we have a 10 and a 30. Let's create a 14%. Okay, so you're gonna have to mix the two together to create a 14% solution. And when you're done, I need 100 gallons of it. So you need to know how much of each one you have to mix to get exactly 100 gallons. There's your first equation. And it also has to be 14% concentration. Okay. So because there's a requirement about how strong it is and how much of it you have, you got to set up two equations. Okay, so the first equation you set up is just for the total amount. If I had two solutions and I'm going to mix them together to get, I think I said 100 gallons, I would just say I have X liters of the first solution, Y liters of the second solution, and X plus Y equals 100. If that was the only condition, there's a lot of answers. mix two things together to get 100 gallons or liters. You could do 50 and 50. You could do 25 and 75. You could do 90 and 10. But if you do those different amounts, you're not going to get the right concentration. So we gotta get that too. And that's the second equation. So notice the pattern in the second one. It's always a concentration times an amount plus a concentration times an amount. And that's equal to the final concentration times the final amount, or the total. So this would be the concentration of solution 1 times how much of solution 1. Concentration of solution 2 times how much you use of solution 2. And then the final concentration times the final amount. And once we set up the two equations, then we're going to have to solve it. So this is called a system of equations because you have two. And does anybody remember from algebra a method that you can use to solve a system? So FOIL is what we generally use when we have to like simplify something with distributive property. So it's a good thing to use, and it may come up when you're doing this, possibly, but it's not one of the methods for solving a system. Anybody remember another method? Well, let's start to set it up, and maybe when we get the equations all set up, then we'll remember the methods. Okay. Oh, we don't need that. Okay, so here's our problem. We've got two solutions. A and B are probably going to be the letters we want to use in this problem because they've already given us those letters. So I wouldn't switch to X and Y. I'd just use A and B. So solution A is going to be a solution that is 10%, and solution B is 25%. So what I mean by the percentage, so let's say you had a 100-gallon barrel in front of you. If you wanted to make a 25% solution, you could take and pour in 25 gallons of a pure chemical, whatever that is, and then pour in 75 gallons of water. So you've diluted it. So the barrel would only have 25% concentration. The rest of it is just water. Okay, so we got a 10% and a 25%. We're going to mix the two together so that when we're done, we end up with a total of 15 liters, and the solution has to be a 12%. One thing that is important is this number has to be between those two. If you have a 10% and a 25%, you could never mix them to make like a 50%. That's not possible. The ones you started with were too diluted to make 50%. But you can always mix them together to make something in the middle. That's how this works. All right, so how much of each solution do we need? Okay, that's what we don't know, but we do have variables that can represent it. So A is going to be the number of liters for solution number 1. B is going to be how many liters we use of the second solution. So number of liters of solution 2. And when we mix the two together, how many total liters do they want us to have?
15.
15. So we're going to start with this equation. A plus B has to total 15. When you mix the two together, that's the amount we want to have. And if that's all you knew, there's a lot of answers. It would be any two numbers that add up to 15 that aren't negative. But we also have to make sure we get 12%. So now let's start to fill out the second one. What's the concentration of solution 1? And it has to be as a decimal. 0.1. So we got 0.1. How much of solution 1 are we going to use?
10%.
So how many liters of solution 1? A. Yep, we don't know yet. So that's A. Plus, what's the concentration of solution 2?
0.25.
That's 0.25. And how much of solution 2 are we going to use?
B.
B, we don't know that yet. And the last part, the final concentration times the final amount. What's the final concentration they want us to end up with? 0.12. And the final amount of liquid when we're done? 15 liters. Okay. So there's our two equations. Let's take the second one and simplify what we can. So 0.1 times A, we'll just call that 0.1A. 0.25 times B is 0.25B. Okay, and the right-hand side, we can do that out. That's just a calculation we can type in. 0.12 times 15. So we got 0.12 times 15.
1.8.
Yeah, thank you, 1.8. Okay. So I'm just going to write down our two equations together now. A plus B equals 15. And that one. Okay. So that's what we need to solve. That's a system. Two equations, two letters. Does anybody remember a method that we can use now to solve that? All right, we can plug something back into something. What's that method called? When you substitution. Yep, that's the method we're going to use, substitution. So to use substitution, you've got to pick one of these equations and get a letter alone. Which equation, you can use either one, but which equation do you think is easier to work with right now? Which one? Equation 2, yeah. I definitely think equation 2 is easier to get something by itself. What letter do we want to get by itself in equation 2? A. So that means you'd have to put the B on the other side. And how would you do that?
Subtraction.
Subtract it. Okay. So now we know A is 15 minus B. What are we going to do with this 15 minus B? Yeah, we're going to take this, and we're going to fill it in parentheses right there. So change A to what we just said A equals, 15 minus B. If we do this step right when we're done, the only letter left in the top equation is going to be a B. Shouldn't be any A's left. Okay, so we got 0.1, and this is where you're going to have to distribute. So it's 0.1 times whatever you fill in for A. So it's going to be 0.1 times both of those. And then the rest is going to stay the same. Okay, so we did this earlier in another problem. We're going to distribute it. What's 0.1 times 15? 1.5. How about 0.1 times negative B? Yeah, there's nothing we can do with that. And now we've reduced this word problem to just a linear equation where we combine like terms and get B by itself. Okay, so I do have some like terms. I've got negative 0.1B 0.25 be? What do you get when you do 0.25 take away 0.1?
0.15.
0.15.
Oh, sorry.
Yep, 0.15.
I was looking at the first number, I'm sorry.
Oh yeah, and then we still have the one, I know it's a little confusing. You got 1.5 because that was times the 15. Okay, 2 steps left to get b by itself. What would be my second to last step?
Subtract 1.5.
Okay, so we're going to minus 1.5, good. That's gone. 1.5 minus 1.8 minus 1.5 gives you 0.3. And how about, Remy, what would my last step be to get rid of that 0.15?
Divide.
Yep, perfect. And divide, and what are you going to divide by?
0.5.
0.15. And these actually are nice numbers. Does anybody know how many times 0.15 goes into 0.3? 2 times. Okay. So we just solved for the amount of solution 2 that we need. Okay. A second solution, we need 2 liters. So then how much of the first solution do we need?
13.
13. Because remember, we're mixing them together to get a total of 15. So if you're going to use 2 of one, you need 13 of the other. And that's the amount of each solution. If you mix them together, you'll get exactly 15 liters, and it'll be exactly 12% concentration. Okay. So, any questions on that? That's a pretty typical mixture problem. Yeah.
I know there's another way to do like a solid system. What was the name for that one?
There's also elimination.
And that's-
So we didn't do elimination here. We could have. We would just have some decimals to deal with. So you'd probably want to multiply everything in this top equation by 1. You'd have to multiply it by 100 first. So your numbers are going to get really big. But yeah, you could write this as a nicer equation if you multiply it through by 100. But yep, there's substitution, there's elimination, and there's also graphing. Okay, you can graph and see where if you put these as lines where they cross each other. Okay, I think elimination was the easiest way to do it. All right, so last type of equation for today. Okay, so quadratic. Okay, quadratic equation is still something you can set equal to 0, but this time the highest exponent has to be a 2. Okay, so anything that has that form, the highest exponent would be a 2. So examples, well, this is the simplest one. In that case, the B is 0, the C is 0, and the A is 1. You could also have as complicated as this. That's a quadratic that has every term. You could also have one where you're missing the middle. There's no x term there, but that's fine. As long as the highest exponent is a 2, it's still a quadratic. So same kind of things you can't have. You cannot have something with like a letter in the bottom. You can't have anything with a square root in it, with a letter under the square root. Okay, you can't have that. You can't have anything like x to the 3rd power. That's not a quadratic, that's a cubic. You also can't have anything like this. Y equals x. What would y equals x be? That's linear, that's not quadratic. Okay, so to be quadratic, it's going to be one of these ones I didn't cross out. Any questions on that? So a couple different ways to solve a quadratic. One way is to factor. Okay, so we'll kind of quickly go over how you factor. I'll make a little chart. So what we have to do first is separate it into two sets of parentheses. And the first thing you do is you figure out what's going to go here and what's going to go there. Whatever you put under those two spots that I underlined, they have to multiply together to give you 2x to the second power. So what would go in each spot?
2x and then 1x.
Yep, 2x and a 1x. Because 2x times x is 2x to the second power. Now, 2 is actually a nice number to have there because it's prime. That means there's only one way you can get 2 by multiplying things together. 1 times 2. If that number was something like 12x squared, well, then we've got to look at all the different ways that we can get 12. 12 times 1, 6 times 2, and 3 times 4. And it could be any of them. But in this case, we didn't have to deal with that. Okay, next step is we've got to figure out our signs. Okay? And the options are 2 plus, 2 minuses, or 1 of each. This is the middle. This term is called the constant. So we can make a chart that tells you what signs you need in the parentheses. All right. And then these will be the final signs when you do your factoring. So we could have 2 pluses for the middle and the constant. We could have a plus and a minus. We could have a minus and a minus. Or I think that's the last one. Yeah. Okay. If the middle is a positive and the constant is a positive, which is not what we have here, when you factor, it's going to be a positive in each set of parentheses. Okay, the second one, that's what we have. The middle is a positive. The one on the end is a negative. You need 1 of each. If the middle is a negative and the constant is a negative, again, we don't have that, but if we did, you still need 1 of each. And the last case you can have is if the middle is a negative and the constant is a positive, you need both negatives. Okay, so this chart takes all the guesswork out of the signs at least. So we know we have to have a plus and a minus. And it does matter which one we put where. I'm going to try them in that order. If that doesn't work, the worst thing that happens is I got to switch them. Try that. Now, here and here, we need 2 numbers that are going to multiply to give us 3. Nice thing about 3, it's also prime. So there's only one way to get 3 as a product without decimals. What are the only 2 numbers that are not decimals that multiply to give you 3? 1 and 3. And I'm going to try them in that order. Okay, so now this is where somebody had mentioned like FOIL or distributive earlier. That's how you can check this and make sure you did it right. So 2x times x is 2x squared. We know that because we picked those 2 for that to happen. -1 times 3 is -3. Oh, we know that too. We picked those 2 numbers. This is what we didn't pick. We have to see if that works out. What's 2x times 3?
5x. Oh, 6x.
6x. And what's -1 times x? -1x. What's 6x minus 1x? Perfect. That's what we wanted. If we had gotten something like a -5x, we got the opposite of what we wanted right there, we would have switched the signs. If we didn't get the right number at all, like a 5 or a -5, then we would have tried switching the numbers, the 1 and the 3. Okay. So that's the hard part. We've taken this and we factored it into two factors. Now we have to set each one of these factors equal to something. Anybody remember what you set each factor equal to?
0.
Yep, set them each equal to 0. So either 2x minus 1 equals 0, or x plus 3 equals 0. And now that's where it connects back to what we did before. We've got two linear equations. So you get 2x equals 1, or from the first answer, we're going to end up with x equals 1/2. Yep. And the second answer, that's just one step.
-3.
We get x equals -3. So if a problem factors, then factoring is generally pretty quick. What if a problem doesn't factor? Does anybody remember another way that you can solve this kind of equation? Yep.
I remember the name, but wasn't it like splitting the equation into like the middle is equal to the C or something? I can't remember the name for it.
So yeah, anybody remember the name of the other way you can solve a quadratic equation? Anybody remember the quadratic formula? Yep.
Am I supposed to tell you what the quadratic?
Sure. Do you remember how the quadratic formula starts?
Isn't it a fraction that's negative b
Yep.
plus minus the square root of, I think, b squared minus 4ac divided by 2a?
Yeah. That's the quadratic formula. And the a, the b, and the c come from here, here, and there. A is the number in front of x squared. B is always the number in front of x. And c is the constant by itself without any letters, but you have to make it equal to 0. If it's not equal to 0, you do that first. So like in this one, A is 3, B is 2, but C is not -5, because you're going to put that -8 on the other side. C is really 3 in that problem. Okay, so that's the quadratic formula, and this method will always work. We could have even used this formula on this problem. It's just because it factored, it was less algebra to factor it than it was to use quadratic formula. But technically, you could always use quadratic formula. This part that's underneath the square root, that's called the discriminant. That's just the name for the part under the square root. That's what I just said to you. If you're going to use that formula, make sure your equation is set equal to 0 first. That's called the standard form. And let's try solving this one. Okay. And for this one, we'll do quadratic formula. Okay, so first step, is that equation in the right format?
No.
No. What do we have to do to get it in that standard form?
Subtract 1 equal to 0.
Okay, so let's get it equal to 0. Now we've got it in standard form. Off to the side, let's make sure we identify what these are. You know which one is which. What's A in this case? 2. That's the number in front of x squared. B, it's also 2. Coincidence, so that's the number in front of x. And what about C? -1. So we're going to take those three numbers, and we're going to fill them in for A, B, and C. In the formula right up there. So let's start negative b plus or minus. What's the first thing under the square root? So what is it in the formula?
B squared.
B squared. So what's b squared in this case? 2 squared, which is 4. So b squared minus, and what's the next part we got to plug into? Minus what? 4ac. So 4, a is 2, and c is negative 1. So minus 4ac, and that's all divided by what? 2a, and in this case a is 2. So what's 2 times 2? 4. Okay, so let's simplify that and see what we get. So we have 4 minus, what's 4 times 2 times negative 1?
8.
Negative.
Oh, I'm not multiplying the negative 4. That's a part of it.
So what I did was I had written down this negative already, so then I just did what was in that box.
Oh, I see.
So I had 4 minus, and then I did 4 times 2 times negative 1. But now we got to look at what happens there. 4 minus minus 8 is going to turn into what?
Addition.
Addition. Yep. So that's negative 2 plus the square root of 12 over 4. Now, once we get that, we just got to look at the square root. Can we break up the square root of 12 so it's a product of 2 numbers? And one of them is something you can take the square root of easily. Yeah, you could break this up into 4 times 3 is 12. And you can split that into 2 square roots. Just like that. So what is the square root of 12 once you simplify it? Yeah, 2 times the square root of 3. So anytime we get a square root, we do have to simplify. That's not quadratic formula, that's just like arithmetic with square roots. Okay, we always got to simplify. So we get 2 square root of 3 divided by 4. And now if you look at all the numbers on the outside, what are they all divisible by? Yeah, they're all divisible by 2, which we might not have known until we simplified the square root of 12. How many times does 2 go into 4? 2. How about 2 into 2? 1, and 2 into 2 is 1. So the final answer we're going to get is negative 1 plus or minus. You don't have to write 1 times the square root of 3. You just put square root of 3 over 2. Okay, so that would be a fully simplified answer to a quadratic. This step doesn't always happen. If you ended up with something like, let's say you ended up, I don't know, square root of 14 here. Well, the square root of 14 doesn't simplify. There's nothing you can do with that. But in this case it did, which then led to dividing everything by 2. Okay, so that's quadratic formula. Any questions on that? Okay. Okay, so let me just double check that. Yeah, that's fine. Okay, so homework on page 96. You've got a little bit of time, so please use the time to try to start that. You've got like 20 minutes. I can walk around and check in if you got any questions, need help with anything. Now's a good time to ask. And we'll go over that first thing tomorrow, and then we'll look at our next section.